హలో సార్, భవానీ శంకర్ సార్.
సార్ చెప్పండి సార్. అలీ సార్ చెప్పండి సార్.
హలో సార్, భవానీ శంకర్ సార్.
అలీ సార్ చెప్పండి సార్.
అది వీళ్ళు మీటింగ్ లో జాయిన్ అయిన పార్టిసిపెంట్స్ ను వాళ్ళు రిమూవ్ చేస్తున్నారంట. కొంచెం ప్రివిలేజెస్ కొంచెం చూడండి సార్, ఏమైనా రిమూవ్ చేయకుండా. అంటే కొంతమంది పార్టిసిపెంట్స్ జాయిన్ అయినాక వాళ్ళని రిమూవ్ చేస్తున్నారంట వేరే యూజర్స్.
ఓకే,
ఆ ప్రివిలేజెస్ కొంచెం వాళ్ళు వేరే యూజర్స్ రిమూవ్ చేయకుండా ఉండేటట్టు ఏమైనా ఉంటే సెట్ చేయండి సార్.
ఓకే 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 సార్. థ్యాంక్ యూ సార్. థ్యాంక్ యూ సార్. Good morning, everyone. Thank you for being here this morning. I'm very much excited to introduce speaker of today's session, Professor Srinivasa Naresh Vanka Mamidi. Sir, presently working as professor in the Department of Computer Science and Engineering in Sri Vasavi Engineering College Autonomous, Tadepalligooda. Sir received Best Research Award from Governor of AP in 2013 and given an invited talk on elliptic curve cryptography, Diffie-Hellman techniques extended for the multiple two-party keys at a time for Inter-University Faculty Forum on 23rd 11 2013 through video conference organized by Government of Andhra Pradesh, APA, CHE and CCE. And also, sir, acting as member of Board of Studies of Computer Science and Engineering, Department of Pragati Engineering College, NAC A grade, and permanently affiliated to JNTU Kakinada. And sir completed UGC minor research projects entitled with a probably secure dynamic authenticated contributory group key management protocol using elliptic curve Diffie-Hellman with a financial assistance of 3,70,000 rupees. And sir published a considerable number of research papers in Science Citation Indexed and Scopus Indexed free journals like Springer, John Wiley, Taylors and Francis, Elsevier, MPDI, Heinwey, Web of Sciences, and etc. And sir published 2 patents on blockchain's group key management, qualified for CSIR JRF as one among top 16 in India in mathematical sciences in 2008, and qualified NET in 2 subjects, computer science and applications and mathematical sciences, conducted by UGC and CSIR respectively. And sir working as an editorial board member for various international journals, Information and Computer Security ICS, and Wireless Communication Technologies WCT. And sir has taken a charge for the reviewer for prominent science index journals, IEEE, Access, Springer HCIs, Willy, IJCS, Willy ETT, IET, WWJ, and International Journal of Network Security. And sir, taking the copyrights for the 2 representations. One is for the Naresh Sivaranjani Bosubabu NSP, Intelligent Self-Driven Multiple Shared Key Algorithm, and for the Quantum Dynamic Group Key Agreement Protocol. So we very much enlightened, sir, to be have a resource person for today's session. Thank you, sir.
Okay. Thank you very much for your introduction. First, I'll introduce myself. I am Dr. Naresh from Dean Research and Development, Sri Vasavi Engineering College, Tadepalligudem. Okay, in this session, uh, the topic is blockchain overview and research perspectives. So first, I am going to present about what is blockchain and what is the purpose of blockchain. After that, we'll get into some topmost use cases in it. So, in today's world, the three buzzwords are very, very important. It may be security or whatever it may be. It may be machine learning. It may be wherever data we need security, privacy, and trust. These are the topmost buzzwords. So, to deal with trust, blockchain is a wonderful weapon. Okay, so I'll say one thing. Invent, Invention is not only creating a new thing. If you use an existing thing for a better purpose, that that might be also an invention, because we have a weapon, blockchain. So you can use this blockchain in many use cases. So before going to enter or going to apply somewhere, first you have to know what is blockchain and what is the purpose of blockchain. Okay, so before getting into this, first I want to uh, give a clear view on why the blockchain is required. So before entering into this, so first, what is blockchain? Blockchain is nothing but it is a distributed ledger. Okay, so you are having many centralized systems. So if you take any website or anything, railway reservation system or banking, you will have a central server. If somebody there, you will provide many securities like firewalls, etc., etc., etc. But if somebody hacks it, or if somebody hacks it, we'll have a problem. We'll have a problem. But to encounter that, or another thing, if the server collapses, entire system will be collapsed. Entire system will be collapsed. So there is a need for decentralization. Decentralization. That means believing only one person, trusting somebody is a threat to security. Is a threat to security. No doubt about that. So the main invention of blockchain is based on disintermediation. There is no intermediate person. If you don't require an intermediate person, then we'll have trust. So I'll explain this. If we trust only one person for getting a group communication, let us assume. So if you want to communicate with a group of members, all the group members must know a key. Must know a key. So with that key, the entire this communication is encrypted and decrypted, and everything will get the information. Okay, fine. But this key can be done in two ways. One, by trusting one person, that the trusted person will give the key to all the persons. If the trusted person is misbehaved, and if he has given this key to other members out of this group, then what happens? Then what happens? This information will be gone to the unknown persons or dangerous persons. Then we'll have greater loss. So that, so how to solve this? So that means you have dependent on one person here. You have dependent on one person here, and we have trusted one person. Uh, Bhavana Shankar, don't move, don't move. I am explaining introduction first. So we have trusted one person. I am giving an instance, a situation. So if you can do, if the trusted person misbehaves, the entire system will have a loss, greater loss. So that for that, what we have to do? If this is happened with contributory nature, that means for generating that key, all the, suppose let it be 10 members are there in that communication. Every member will give some share, some part only. If all the 10 parts combined, then only the key will be generated. That means no one can influence the entire communication. That means it is a contributory. It is a contributory. So if the trust is based on many people, then we'll have a greater trust. So this is contributory. So here, as not in traditional centralized systems, here we are having decentralized system. Here, instead of having one server, we'll have many thousands or lakhs of servers. In this digital ledger will be available with every member of that blockchain system, every member of blockchain system, so that everyone can view what is happening. There we'll have trust. There we'll have trust. See this blockchain. Here, what is blockchain? Blockchain are an emerging technology pattern that can radically improve banking, supply chain, and other transaction networks. And we can use blockchain in healthcare. In today's session, I'll explain how blockchain works in healthcare. That is a wonderful healthcare application we'll have today. Okay. So before going to that, first, how to create a blockchain. So in the blockchain, first we'll have transactions. We'll have transactions. So we have to add these transactions one by one to create a block. After creating a block, we'll create another block. We will create another block, and we'll connect these blocks as a chain. These blocks as a chain. That is nothing but blockchain. So blockchain is a distributed ledger. Distributed ledger. Okay, you can see transaction, block, and after that blockchain. Go for next slide. So, Bhavana Shankar, next slide. So here we can link the blocks like this. And we are having wonderful funding for this blockchain. It is rapidly growing day by day. It is rapidly going day by day. And we are having previous slide. It is rapidly growing day by day. So that if you can focus on this blockchain and their applications, you will have a wonderful career in research or whatever it may be. Okay, so the blockchain contains three things. Okay, one, we are all know Bitcoin. In 2009, that was evolved. So in Bitcoin, what happening? So it has made a revolutionary change in banking. So what happened there? We doesn't need any bank or bank. We need not trust bank. So there is disintermediation. So that Bitcoin is a blockchain. Okay. So that is an application of blockchain only. So next slide. So blockchain contains three mainly. One, next slide. A distributed shared ledger. A blockchain is nothing but a distributed network. Previous slide. Distributed network, and it is a distributed network. That means it is a decentralized peer-to-peer architecture. It is a decentralized peer-to-peer architecture. Okay, with nodes consisting of network participants. So we may have, instead of having only one server, we will have thousands or lakhs of nodes. And these nodes consisting of network participants. And each member in the network stores an identical copy. This identical copy, that shared ledger, is available to all the members. Is available to all the members. So what is shared ledger? What is shared ledger? Shared ledger is nothing but it is a recorded digital transactions. Record digital transactions. So into a shared ledger. To add a transaction, member in a network run, evaluate, verify. So here the trust comes out of this. If you want to add a transaction, first we have to verify. There should be some consensus. Actually, everyone doesn't have a right to add something. So if they want to add some transaction, it should be verified by the remaining persons. There are various algorithms. Based on that algorithms, if it is accepted by majority of the people, then only the transaction will be added. So majority of the members in network should agree so that the transaction is valid, so that we will have some trust. We are not based on one or two persons. We are based on majority of the people, so that we will have trust. Next. Next. So changes to share. If somebody wants to change a shared ledger, that should changes to shared ledger are reflected in all copies of the blockchain. So here, if somebody, if a person is there, he is having shared ledger, he cannot modify the shared ledger. So if it is done, if there is any modification done in shared ledger, that should reflect in all the copies with the consensus of all the persons. So that's why if some transaction is added to some block, it is immutable. It is immutable. That means we cannot change it. We cannot remove it or we cannot delete it. So we cannot change it. That is immutable property. Since all the members in the network have complete copy, blockchain, no single member has a power to tamper or alter. That is the trust. I already told with a wonderful instance. If the thing is contributory, whatever the thing is contributory, whatever work or whatever the thing, if it is contributory, it will have more security than based on single person. Based on single person. So that is the trust with blockchain. And here you can see a digital transaction. So a digital transaction, any type of information or digital asset can be stored in blockchain. And the blockchain defines type of information contained in the transaction. So that is a digital transaction. This information is encrypted and digitally signed. So there we'll have authenticity and accuracy. Okay, so we'll have encryption, so that we'll provide security for these digital transactions. You can see a blockchain is like this. So there are various shared ledgers, and everywhere the same copy will reflect, and all are peer-to-peer network. This is peer-to-peer architecture. We'll have like this. Next slide. Next slide. So like this, we'll have a blockchain is like this. This is a P2P architecture, and these are all shared ledgers. They are connected to each other. This is a peer-to-peer network, and every member of the blockchain will have a copy. Will have a copy, and no one can modify on their own. If the consensus are there, then only they can modify. And another wonderful property is encrypted and digitally signed, you all know, and each block is connected to the prayer block. Each block is connected to its prayer block. I will explain in an order. Okay, this is blockchain. So here you can see. So I am showing a simple blockchain with only two blocks. Next. Simple blockchain with only two blocks. Okay, here you can see block number, timestamp, nonce. So here you are having data, financial transaction, some data, financial transaction here. What happens is, for this data, we'll apply hash. You all know about hash. Hash is a function. Hash is a function. So if you apply hash on some data, we'll get some fixed number. Okay, so if you apply hash on this data, we'll get some number. And we'll store this hash value in the previous block, in block 2. This hash will be saved. So you can see these two are same, 1 0 0 1 2 3. So this is hash of this block 1, this value 0 0 1 2 3, but this was stored in its previous block. The same previous hash will be stored here. But if somebody changes data in block 1, what happens? This hash will be changed. Here 0 0 0 1 2 3. If you change the data, it may be 0 3 1 4. Then what happens? Then block 2 is linked to block 1, and these two hash values will be not equal, and they can realize that there is a change that was unnoticed by the other parties is done. So if the both hashes are same, that means there was no change happened. If somebody illicitly or unauthorizedly changed the data, then hash will be changed, and this hash will be saved in the previous block. And if the hash changes, those both will be not equal. Then the people will recognize that there was a unnoticed change happened. Unnoticed change happened. Okay, so that is about blockchain. About blockchain. Okay, fine. Is it clear? Is it clear? This is very, very important property. Here there is a trust. Here there is a trust. That means if the hash changes, if the data changes, hash will also change. But this hash value will be given in previous block. And if these two contradict, what happens? The hash has changed. So if the data is changed, that every link of hashes will be reconstructed or re-evaluated and will be given correctly. Then only it is happened with the consensus. Okay, fine. So the hash mechanism will give a trust. Fine. Next. So here you can see, next slide. Here you can see. So actually this is centralized system and blockchain is a decentralized system. So if the server collapses, the entire system will be collapsed in centralized system. And here we have to trust and we have to base on the centralized server. If anybody hacks the centralized server without notice of us, we lose. We lose. Whatever security, previous. So whatever security you may have. But here you can see, here you are having, instead of one server, we'll have many, and every node or every member will have a digital ledger available. Same copy will be available with all the persons. And if one node collapses, no problem. Remaining nodes will be there and they will work. Nothing to worry. So there are wonderful advantages with blockchain, and there is wonderful trust because all the blocks are connected to each other. If there is any change reflected somewhere without notice of the others, that should be clearly visualized by the other people using hash so that we'll have wonderful trust in blockchain. So that is the wonderful storage you can have with blockchain, with providing security, privacy, and trust. Okay, next slide. So here you can see how the transaction will be added to blocks. Next slide. Slide. Okay, here someone requested transaction. Here you can see someone requested transaction. After that, in P2P network, P2P network consists of computers, comma, known as nodes. These all computers are known as nodes. After validating a transaction, so here you can see 1, 2, 3, 4, 5 nodes are there. So 4 are accepting tick. Then this transaction is verified and validated, and this should be added to create a new block of data for the ledger. We'll add this transaction. So after getting a block, new block, we'll add to the new block is then added to the existing block. So we can have blockchain. So the transaction is added. So we can make blocks like this, and we can make, first we have to take a transaction. It should be validated by the taking consensus of majority people. After that only we can add the transaction to a block, and we can create a block with a collection of transactions. After getting those new block, we can add this block to existing blockchain. Fine. So next, we are getting into next slide. We are getting into types of blockchain. Actually, blockchain is transparent. It should be known to anybody, open. But there are certain examples or certain use cases where we need some privacy, so that it should not be open to others. So that we'll have various types of blockchain. One is public blockchain. It is permissionless. There is no permission. Anybody can join in it. So DLT, that anyone can use this to be a part of blockchain network as an authorized node. So this is public blockchain, and this is Bitcoin. Bitcoin and Ethereum. These comes under this public blockchain. So after that, we will getting into a private blockchain. So private blockchain, here we will have only with permission only the person can join, member can join. With permission are restricted DLT that can work only in a looped network. These are used within an enterprise or organization. Okay, if an organization or enterprise needs some security within those, then they will use this private blockchain. This private blockchain, and there is another blockchain. So in today's session, we'll discuss healthcare. There we can take this block, a consortium blockchain. It is a collaborative nature, semi-decentralized DLT, and in contrast to the private blockchain, it can managed by organization in similar nature. If there are some organizations, that means you can take some Apollo hospital, some Star hospitals, some care hospitals. There are various organizations. These all can collaborate for a purpose. So in healthcare, like that analytics, we can use this consortium blockchain. I'll get back to you next in the use case. Okay, fine. Next slide. So next is hybrid blockchain. Hybrid is, this is combination of public and private, nothing else. So here we can see in healthcare we will use consortium blockchain, because we have to take the data from various organizations, so that we will use consortium blockchain. Okay. The next use case, blockchain based. Now I am getting into up to now I have explained what is blockchain, what is the purpose of blockchain. So what are the types of blockchain? So what is the how it is impacting security, privacy, trust with decentralized nature. I explained all these things. Now I am getting into wonderful use case, blockchain in healthcare. So blockchain based security, privacy, trust in healthcare. So how you are going to incorporate security, privacy, trust in healthcare? Because healthcare data, there are many breaches. There are the highest breaches, data breaches are in healthcare. I'll show later. Those statistics I'll show later. So now you are going to discuss this. So here, this is the situation. Next slide. Here, if you take an healthcare information from providers, we are having many type of things. So doctor, we can take heart monitoring, lab results, blood pressure, biosensors, and MRI, and prescriptions. You can take data from all these things, and we can encrypt these things, and we'll store. What we'll do is, we'll store the entire data in some data lake or some cloud. We don't store the data in blockchain, but the respective address of the data will be stored in blockchain. So whenever we require certain data, we can query the blockchain, and blockchain will show the specific address, and with that address we can take that data from cloud or lake. So that is the entire process of this healthcare blockchain. I will getting into later, okay, in detail. So here you can say, so patient use device to assign, next slide, assign access permission to data and to provide public key. And provider uses health application to access health data. So healthcare data must need high privacy. Why? Because if you know a person's healthcare data, like what is his BP, what is his BP, sugar, and heart rate, and any other issues with heart or kidney, etc., etc. If it is out, then there is a lot of loss for him, because marriage, while getting into marriages, if this data getting out, there is a problem. So the privacy and security is highly needed in healthcare. So that we have seen, we are gone for this healthcare application in blockchain. Okay, so I have already explained, we can collect data from various things, and we can put the uh, respective address in blockchain and corresponding data in data lakes. So we can take that, and after getting this data, after taking this data, we can see some healthcare analytics you can take, and we can apply healthcare analytics, and after that we can make decision like machine learning or deep learning. We can have these things. So next slide. Here you can see healthcare organizations direct information to blockchain. So various healthcare organizations will direct information to this blockchain. So those data will be added to blockchain, and a blockchain will be constructed. So transactions are completed and uniquely identified. And after that, health organizations and institutions can directly query blockchain. I already told. If anybody needs some healthcare data, they can query, I need this data. So then there is some permission. So based on that permission, we'll have smart contract. Smart contract will give those permissions. That is a program, nothing but that is a software program. Okay, based on that, they will query, and based on permission, they will get the data from healthcare organizations. So patient can share their identity with health organizations, and also patient can share their identity with the health organization, because they are an encrypted form only. So advantages. So blockchain technology offers many advantages. Healthcare IT. Blockchain is based on open source softwares and community hardware and open APIs. The components facilitate faster and easier inter interoperability. I'll explain that. That is a very, very important concept in healthcare, because what is interoperability? I will getting into it later. When it comes, I'll explain what is interoperability. Please keep it mind about interoperability. I will explain that later. So here, so we'll have blockchain as a open source software. Okay. So, and it is reliable and robust under fast changing conditions that can be matched by closed and proprietary software. And open source solutions are having here, and we'll have wonderful trust and security and privacy, and creation of a single storage location for all health data, tracking personal data in real time, and security to set data access permissions. So this is very, very important. Security to set data access permissions. Based on the data access permissions only, the data will be revealed or given. Okay, while queried, based on that data access permissions only, that will be given. So there should be security that will be taken care by smart contracts. Okay, the most efficient and effective approach for advancing interoperability. Again, it comes. That is very, very important concept. I will come into later. Later, I will come next. So these are all interoperability, utilization of the proposed healthcare in blockchain, and acquisition, storage, and sharing. These are all the advantages of blockchain in healthcare. Okay, blockchain has the potential to sustain sustainable sustain sustainability impact in healthcare industry. No doubt about that. Okay, blockchain can prove authentication and prevent modification. I already explained. So nobody on his own cannot modify the data or cannot delete the data. It is immutable. And there is a wonderful trust mechanism with hashes, and after that proof of work and proof of stake also there. So with that, their wonderful mechanisms are there. So patient data can be managed with blockchain in a wonderful fashion. I'll explain later. So blockchain provide a secure structure, no doubt about that, for healthcare environment. Okay. Next, next, go next forward. Blockchain can address patient consent for data sharing not addressed by HEIs. So based on the consent of patient only, the data will be given access permission. For example, Bhavani Shankar is there. His family doctor is there. If in the smart contract, the access permission will be given regarding Bhavani Shankar's health information to a specific doctor, his family doctor, let us say Srinivas. So if he queried the blockchain, then only the data will be given. Otherwise, if the other person queried, that won't be given. So that is called as access permissions. Okay. This can be done by smart contract. System of smart contract, a rule-based method or access. Okay. So if a query is done, then smart contract automatically reacts and give access if there is access permission for the specific person, doctor or patient, whatever it may be. Next slide. Okay, fine. Store certain data on blockchain, but still allow certain data to be accessed by secure links. Okay, on blockchain, data could include age, gender, and other personally identified information be of size and type stored and immediately viewable. Our blockchain data could include images, medical data, also we can store. Okay, format may have different requirements. Okay, but we can store those images, etc. Next slide. Forward up to significance slide. Next. So now I am going to present a wonderful use case. Next. Significance. These are all already covered. Okay. So this is very, very important. Okay. Now I am going to give some statistics. Increased life expectancy results in large aging population in the next 2 decades, coupled with inability of elders and disabled people to afford medication. Okay, so now I am going to present a use case project, which is highly helpful to all in general, but it might be very much helpful to the elderly people and disabled people. So you can see this aging people are growing day by day, as you can see. So this must be very, very important if you can establish such type of project. So smart, secure, reliable, cost-effective healthcare system. We are going to build a cost-effective healthcare system with security, reliability. Okay, that's we are going to build. So what is the need? So here you can see healthcare data breaches. So every organization like care hospitals, Apollo hospitals, Star hospitals, they will have healthcare data, but that should not be given to everybody. But people won't leave and they will try to breach the data. Actually, you can see the statistics here. 44% of all data breaches are healthcare. Okay, related versus 37% are financial data breaches. So only 3.7% is financial data breaches, but 44% are healthcare data breaches. So that this blockchain and healthcare will have a greater role, and it is very, very important. And 40 million patient records are estimated to have been stolen since 2009. 2009, from 2009 onwards up to now, 40 million patient records were stolen, health records were stolen. And it is increasing annually 138%. So this is the greatest need of blockchain in healthcare. Here you can see 45% of healthcare breaches due to lost or stolen with portable devices such as laptops, tablets, and smartphones. So from these, they are getting this data. They are storing data. So so the main significance of this project is increase in healthcare data breaches and lack of reliability in centralized systems. Reliability, availability, privacy, security, interoperability. I will explain that with the existing centralized systems. So these are not with existing centralized systems. So to ensure trust in medical community, scientists, and paramedical is essential to improve the quality of healthcare. To save massive loss of time, money, eventually life. So if you establish this type of system, so it can eventually save a life, time, and everything. There is no need of patient going to an hospital. Okay, they can get their advices from a personal doctors through this blockchain network. So they will upload or they will give access to their data to a specific doctor, and the doctor will in turn give their suggestions to the specific patient, and he can take the treatment or something, whatever is available to have doorsteps. So at her doorsteps, and they can take medication also. Okay, so these are the advantages of this blockchain. So blockchain integrated, decentralized, secure, and smart healthcare system. That is the main intention of this project. Okay, so what is benefits of this elderly or disabled? Blockchain facilitates personalized, integrated approach to service delivery for elderly. So what we'll do is allow longitudinal data of elderly to be securely stored in blockchain, which they can grant access to the service provider they had engaged. So that means we'll give the address of some elderly person. His elderly person's son is there at USA, but he can monitor and he can view what is happening to his father through this network, and he can be linked with a specific doctor, and he can communicate with the doctor, and he can take care of his parent, however he may be in US. Okay, fine. And with this longitudinal data of elderly stored in blockchain, if there is any emergency occurred, then smart contract will give permission to the doctor, and the doctor will respond based on the situation. If there is any need, they can send some uh, some people or some doctors to the specific area, and they can treat there itself. If it is not needed, they can send some suggestions or medication to the older person. With that, they can be survived. Okay, so and link all product service providers for elderly care with elderly families and caregivers. Okay, so this with this blockchain network, you can connect with their people who are caring these people, and they can view, a son can view his father's health positions, health situation, wherever he is, how much distance he may be in. Okay, so that is the wonderful system we are going to establish and improve efficiency and save cost for the service providers and elderly, leveraging on smart contract for elderly products and services. So the smart contract will be used for giving those permissions. So see this. This is a wonderful uniqueness. Next slide. You can see how this solution, how this system is unique with respect to the previous slide. Project uniqueness from existing solutions. Previous. This is very important. See this. So in existing solution, actually in centralized healthcare systems, we have to trust the intermediary. Third party should be there to store our health records. If you take an hospital, there we'll have a single server. There somebody will enter the data. We have to believe those things. But third party can be eliminated by establishing distributed ledger, which can which has built-in trust mechanism. That is nothing but blockchain. So this is nothing but disintermediation. There is no need of trusting anybody. Okay, so that is one. So cost per transaction is very high as lot of intermediaries are involved. So here we need many people. If you take bank, there are many employees are there. But if you see Bitcoin, there is no that system. Okay, only trusted system you are having. Okay, with that we will save cost and everything. So reduce transaction cost due to disintermediation and as well as nearly real-time processing. And no standard method for identity, no standard method for patient identity. But here every patient will have a public key, and we can use private and public key identifiers which can create and protect the patient identity. Patient identity will be there, but we can protect. And here there is no interoperability, no health data interoperability between systems. Shared data enables real-time updates to all the networks. So interoperability, I will explain this. This is very important concept in this healthcare. So limited access here. This is distributed and secure. So if the single system is collapse, entire system will be out. But here this is distributed and there are many nodes, and if one node is one server is out, the other server is having the same copy with him, and no problem with that. And inconsistencies and no rule permission. But smart contract creates role-based method for accessing patient data and give permissions. Okay, so the main objective of this is build a blockchain integrated smart contract and secure healthcare system for ensuring reliability, security, privacy, and interoperability. So what do you mean by interoperability? I'll explain 1 minute. I'll explain. Interoperability. Here you can see FHIR. Next slide. Next slide. Next slide. Next slide. Next slide. Methodology. Next slide. Next slide. So you can collect various data to this sensor, patient through sensor. We can collect all these data. After collecting these data, secure communication, we have to store this data in blockchain. Okay. So if you take an elderly person, there we'll put some sensors or some code are given with sensors, and with those sensors will collect the data, and after processing those data, that will be stored in blockchain. So here this is the healthcare system architecture. Please listen to this. This is very important. Here you can see this is the top tier. There what we are having, data sharing layer, upper layer, hospitals, companies, governments, researchers, doctors, patients. This is the top layer, and there we need data sharing. A hospital may require some data, and a patient may require some data, doctor may require some data. So the next layer is data storage layer. This is data storage layer. This is data acquirement layer. So the data will be acquired from here. So you can see patient is here. So in the lower layer, data acquisition layer. There we can collect patient data like age, etc., various attributes, address and problem, etc. So we will collect these data and we will sign it, and we can collect data from doctors, and next we can store a specific data in this cloud. the electronic medical records will store here. But the corresponding address or indexes are stored in blockchain. Whenever if some permission is given through smart contract, if a person asked, if a doctor asked permission to get his patient's data, then smart contract will be, so he will query the blockchain. That doctor will be queried the blockchain. Then the smart contract will check whether the access permission is there or not. If there is access permission, they will give the index or address of the specific data of a person to the cloud. So then they can take the data from the cloud and they can work on it. And after that, they can advise the people, okay, advise the patient. The doctor will advise the patient. That is the process we're having here. Here I have said interoperability. That is very, very important. I will give an instance. I will explain with an example. If you take interoperability means we must have uniformity. So if you gone for certain hospital, there they have given certain data in certain format. So if this format is uniform in the entire world, if all the doctors and hospitals follow some standards. So HL7 standard, national standard. Here you can see FHIR server. Okay, so this is interoperability. So if some reports are there with some hospital, if some emergency came and that hospital cannot do anything, they are not having that expertise or specialization, then they have to send this data to other hospital and they have to advise the patient to go to other hospital. While going to that hospital, it may take certain time. So before that, if they can connect these reports with a blockchain network, and if they send these permissions, if they give permission to the other hospital where there are specialized people, and they can retrieve the data and immediately they can find out the remedial measures. After getting the person there, they can be ready with the treatment, and or they can advise something to this hospital also. That is the advantage of this healthcare system. Interoperability is nothing but if the report prepared at this hospital is uniform is in the uniform format as per the other hospital also. So if it is uniform to all the hospitals, then they can understand it easily. That is called interoperability. So for maintaining that interoperability, they have to they have to mm, they have to stick to certain standard, that is HL7 standard. Okay, so with that interoperability they can have, and the treatment should be done nicely, so that eventually you can save a patient, you can save time, eventually you can save a life. Okay, so that is about this. And I have already explained data acquirement layer. So last layer. So there, next slide. Data acquirement layer. Next is explanation of these layers. I have already explained those things. Next slide. Data acquirement layer. There we can create electronic medical record, and we can do various processing, and we will make the data in the data acquirement layer. After that, next slide. Data storage layer. Data storage layer. So there we are having two things. One, cloud storage. The cloud stores the patient's encrypted EMRs, which solves the limited storage capability of blockchain. Actually, I already explained the data is not stored in blockchain. The data is stored in cloud, and respective address or index will be stored in blockchain. Okay, and after that, fast health interoperability resources. The standard was created and is managed by the health level 7 international healthcare standard organization. So there we'll have a specific format. The entire data of a patient will be in that only. That is called interoperability. So after that, data sharing. In the data sharing, next, data sharing layer, the authorized patients and medical workers and health institutes can request the patient EMRs and they can share the data among them based on the access permissions. So access permissions will be given by whom? Next slide. Data sharing layer. So predefined access permissions in smart contract to ensure data sharing securely. So that is the thing we are having. And I have already explained the immutable property. So here we can see hash from block n-1, hash of block n. So previous block hash will be stored in the current block. So if there is any unethical change has been done, it should be noticed by everybody. So it is immutable, non-tamperable. We cannot tamper. Next, and we'll provide privacy preserving also. Okay, fine. Next, 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 next. So we can provide privacy preserving also, and after that, data secure storage and sharing. So elderly and disabled patients, health sensors securely sent to doctor, and doctor integrates EMR to EMR of P. Upon receiving EMR, P stores them to the cloud. Cloud lo store chestaru. Whenever some doctor requires the specific information of a specific patient, they will query the blockchain, and based on the access permission, the smart contract will give the permission. Based on that permission, they will give the data, and after getting those data, they will based on the data they will give the suggestions to the patient or treatment. Okay, fine. Thank you very much for patient listening. If any queries, you can ask, or I will give my mail address and mobile number to Bhavani Shankar. You can take from him and you can ask anytime. But blockchain is a wonderful area if you utilize that in a better way. Bhavani Shankar, please share 3 papers. I send it to you. Actually I published in nearly 25 SCA publications. In I have published nearly 5 to 7 papers in blockchain. You can see, I'll see only. This is a probably secure sharding based blockchain smart contract centric hierarchical group key agreement for large wireless attack networks. This is one of them. This is published in Wiley. Next, show another paper. So you can utilize the existing features and trust in blockchain for any better application. So there is no need of establishing new thing. If you can use an existing thing for a better purpose of the society, that might be give wonderful things to you. Okay, this is another thing. Blockchain privacy preserving smart contract centric multiple multi-party key agreement over large VANets. This is also published in Wiley SCI Free Journal. Next another show. What I presented today, I published that also. Once see next healthcare HC అని ఉంటుంది అది కూడా share. So blockchain based patient centric healthcare communication system, this should be the future, no doubt. I am telling today, next we will have wonderful blockchain healthcare systems in our daily life we'll use in coming days. I like this paper very much. Please scroll down this paper. So this is the use case I have explained today, because we will have only 1 hour time, so that I'll get into that healthcare only. Okay, I am not getting into that key agreements. Okay, thank you very much for your patient listening. If any queries, you can ask, or you can contact me at any time. Thank you very much.
Thank you so much. Dear participants, if you have any queries, you may ask them.
Please share my number
I
also.
think no questions are there, sir.
Uh,
Definitely, sir. Thank you so much, sir. I know how much busy you are in the college as a dean of R&D department, even though you are given your valuable time for us. So thank you once again, sir. In the future also, we will be like this. Whenever we are asking any kind of representations, I think you are will always positive in manner, sir. Thank you so much.
Thank you very much for your invitation. Okay, fine. Thank you.
Thank you. Thank you.
Thank you very much, sir.
Thank you.
Thank you, Krishna University side, sir, for giving this nice lecture on this blockchain technology. Thank you very much.
Okay. Thank you, sir. Thank you, sir. Thank you, sir. Fine.
Thank you so much.
I am leaving. Thank you. Bye.
Dear participants, attendance. Yes, sir. Dear participants, attendance link is posted in WhatsApp group. All the attendees, please fill your attendance form on or before 1:30.
Participants, do remember that attendance on every day is compulsory. So you need to attend all the sessions and you need to qualify an examination to get a certificate for this FDP. So try to be regular.
Participants, attendance link is already given in the WhatsApp groups. All of you, please check in the WhatsApp group and please submit the attendance form on or before 1:30 p.m. Thank you.